Hi, welcome to the Olympiad geometry. Let's continue our study on Excenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Okay, here is a problem. In triangle ABC, X circle in angle B is tangent to CA on D, which here I just draw the X circle in angle B has a excenter as IB here. It's tangent to CA on D, which means that we can simply draw the projection from IB to AC, find the tangent point on D. And X circle in angle C is tangent to AB on E. So similarly, we just find the excenter IC here and find the projection from excenter IC to AB, which is E here. That is a tangent point. Draw a line from the midpoint of D and BC, MN in this case, right? So the midpoint of ED is M, the midpoint of BC is N, and we draw the line of MN. Prove that MN equally divide parameter of triangle ABC and parallel to angle bisector of angle A. So which means we want to prove two things. The first thing is that MN, the line MN, the line MN divide the parameter of triangle ABC equally. And also we want to prove that MN is in parallel to AIA. So for this problem, I actually have two solutions, but I don't want to talk about the second one because it uses a lot of geometry techniques that need to build or construct lots of triangles, which means that you need very strong experience and try a lot to build it, right? Which is not a very common method, and also, I mean, it's a smart method, but it's not very useful for analysis. So here I want to introduce a method that I can think of that very straightforward and very common to see in the problem associated with the excenter, because in the problems associated with excenter, you can always see this kind of method. It's so different comparing to the orthocenter and incenter and the circumcenter, right? For the orthocenter and the circumcenter, we can just think of construct the circumcircle and also find the 9-point circle. Generally, it's very help. And for the incenter, we find we sometimes we use area method, right, to solve the problem. And for the for this one, let's say for the centroid, we also, just when I mention the centroid, we should always think about the relation from the vertex to the centroid and from the centroid to the midpoint, right? That's a 2-to-1 ratio, and that always helpful with solving the problem. But for the excenter, I would say lots of problems associated with excenter just require one thing, or one method is very useful. That is calculation. Okay, just calculate everything. The reason we can do this for the excenter, because we already know the length of so many segments, and also we know the relations of the these triangles, similarity or congruent, right? So That means we can do a lot of calculation on the length of the segment and figure out the relation between two lines. Maybe they're in parallel, maybe they're like perpendicular to each other. So something like that, right? Okay, anyway, let's do that. So think about, we want to prove that MN is in parallel with AIA, right? We do this first. We want to prove that MN is in parallel with AIA, but look at the figure. We don't have, it's difficult to find an angle as a breakpoint to do the provement, right? So let me just mark here. Let's call this point as G. So if we want to use an angle, we need to prove that angle MNC equals to angle AGC, which is extremely difficult. We have no clue what is ANC is, what AGC is, right? It's difficult. So the method here is that just connect the BM, okay? Just connect the BM and extend it. So let's call this point as J, and we connect BM, extend it, meet AG on K, for example, here. Then think about this. We can quickly calculate the length of AE, right? That's based on the property of the excenter. And we can calculate the length of AD, which means in the triangle AED, we know the length of AE, we know the length of AD. And based on the cosine law, we can actually calculate the length of ED if necessary. But of course, we already know that AG is angle bisector of angle EAD. So that means without calculating the real length of the ED, we already know the ratio of EJ to JD, right? We already know the ratio of EJ to JD, which means in the triangle AEJ, we know the ratio of EM to MJ because M is the midpoint of ED. If we know the EJ to JD, we can find the EJ to ED, and then we can find the EJ to EM, right? So we can know all the ratio here of the segments ratios. So let's say we can figure out the ratio of EM to MJ, and then in the triangle ABK, we can still use Mendeley's theorem, right, to find BM to the ratio of BM to MK, which means that if we want to prove that MN is in parallel with AG, we just need to find the ratio of BM to MK and the ratio of BN to NG. For BM to MK, we just talk about how to find it. We use the Mendeley's theorem twice, and then we can find it. For BN to NG, that is easy, right? Because we can calculate for the real length of the BG, and we know the length of BN, which is half of BC. So we can calculate the ratio of BN to NG. Then we can prove if these two are equal, that means MN is in parallel with KG, right? Okay, let's do the calculation here. So the first thing is that we want to calculate for AE and AD. What is the length of AE? Remember that if we do a projection from IC to this side, and we know that this triangle is congruent to this triangle, and this length equals to, if we also do a projection here, this length equals to this length, right? Which means AE equals to half of A plus B plus C, which is this one, and minus this one. Minus this one, right? Minus AC. AC is B, so minus B. It equals to A minus B plus C. Right, that's AE. And what about AD? AD equals to half of A plus B plus C, AD. Here, minus AB, right, which is C. So it equals to A plus B minus C. Okay, we know the length of AE, we know the length of AD. So AE to AD. AE to AD equals to EJ to JD. Right, which means it equals to A minus B plus C to A plus B minus C. That is EJ to JD. Remember that we want to use the Mendeleev's theorem in triangle AEJ. Let's just write it down. So in triangle AEJ and the line BMK, right? We have triangle AEJ and the line BMK. So we have AB to EB. AB to EB times EM to MJ times JK to KA equals to 1, right? So what is EM to MJ? EM to MJ. We already know EJ to JD, right? So based on this, we can calculate EJ to ED. So EJ to ED equals to EJ to EJ plus JD, right? Which equals to A minus B plus C to 2A. Right, that is EJ to ED, which means EJ to EM equals to A minus B plus C to A. Right, half of, so EM is half of ED. EM is half of ED, right? So this one divided by 2, that is A. Okay, we find EJ to EM. Now we want to calculate for EM to MJ. So EM to MJ equals to A to MJ is EJ minus EM, right? EJ minus EM, which is C minus B here. So that's EM to MJ. And now let's put these things back to this equation. So we have, see here, AB to EB. What is EB? EB is A plus B plus C divided by 2 minus, see, EB is here, right? Think about this line, minus A, which is AB is C. So C to half of A plus B plus C minus A here, right? So that is AB to EB time EM to MJ, which is A to C minus B, equals to KA to JK, right? That's what we have here. So it equals to twice of AC to C minus B times minus A plus B plus C. Right, that's for the KA to JK. So we know the KA to KJ. That's a ratio we know. Now we think about using the Mendeleev's theorem to triangle BKA and line EMJ. Okay. Use the Mendeleev's theorem on triangle BKA and the line EMJ. Let's see what we can get here. BE2, that's the other way around. AE to EB AE to EB times BM to MK times KJ to AJ equals to 1, right? Okay, if you understand this one, let's just calculate for the rest part. So AE to EB. What is AE to EB? The length of AE is half of C. That's half of A plus B plus C minus B, right? So A minus B plus C divided by EB. EB of is half of A plus B plus C and then minus A. So that is half of minus A plus B plus C, right? That is AE to EB. And times BM to MK. BM to MK. That's the thing we're looking for, right? And times KJ to AJ. KJ to AJ. We already know KJ to KA. So KJ to AJ equals to KJ to KA plus KJ, right? KA plus KJ, that is AJ. Okay, it equals to 1. Now we do the calculation. So that means BM to MK equals 2. We turn this on the other side. That's minus A plus B plus C to A minus B plus C times KA plus KJ. These two add up together, so 2AC plus C minus B minus A plus B plus C 2 KJ. KJ is this one, so C minus B minus A plus B plus C, right? And now we can see these two can cancel each other, right? So it equals to A minus B plus C times C minus B, right? And expand this one, so we have 2AC plus, or actually minus CA here, and plus BC plus C square minus plus AB minus B square minus BC, right? So it equals to A minus B plus C, C minus B, and on the top 2AC minus CA, that is AC, so these two, and BC cancels BC here, so the rest of the part we don't have anything else, we just write it down, C squared minus B squared. So you can see for this one we have A times C plus B, right? And for this one we have C minus B times C plus B, so we can extract the C plus B out, and the rest part would be A plus C minus B, right? And divided by A minus B plus C times C minus B, which equals to C plus B to C minus B, right? That is BM to MK. Now let's calculate for BN to NG, right? BN to NG. What is BN? That is half A, right? So half A divided by NG. NG is BG minus BN, right? BG is AC to C plus B, and minus BN. BN is half A, right? So it equals 2. We just divided this by half A, so 1, 2, 2C, C plus B minus 1, right? It equals 2, 1, 2, C minus B to C plus B, which equals to C plus B to C minus B. right? That is Bn to Ng. See here? So we got Bn to Ng equals to Bm to Mk, right? Bn to Ng equals to Bm to Mk, which means Mn is in parallel with Ag, right? Ag is an angle bisector. So we just prove that Mn is in parallel with the angle bisector of angle A. And we want to prove that Mn divide the perimeter of triangle ABC equally, right? So for this one, we just think about, we extend Mn to here. Let's call this point as F, right? And from N, we can just draw a parallel line to AB and meet AG on H, right? So we know that AF is in parallel with NH and FN is in parallel with AH, which means AFNH is a parallelogram, which means AF equals to NH, right? So we want to prove that, let me just write here. We want to prove that Mn divide the perimeter of triangle ABC equally, which means we want to prove that BF plus Bn equals to, or we want to prove this, it equals to AF plus AC plus Cn, right? And we already know that Bn equals to Cn. So we want to prove that BF equals to AF plus AC. So basically we want to calculate for the AF. And we already know that AFNH is a parallelogram, so we just need to calculate for NH, right? And how to calculate for NH? We know that NH to AB equals to NG to GB, right? Which equals to NG. We already know the Bn to Ng equals to C plus B to C minus B, right? So C Bn to Ng equals to C plus B to C minus B, which we got that Ng to Bg equals to C minus B to, what is Bg? Bg is Bn plus Ng, right? So these two add together is 2C. So it equals to C minus B to 2C. Right, that means NH equals to C minus B divided by 2. Right, because AB equals to C. So that cancels. So we got the length of NH, which is AF. Then we know that BF equals to AB minus AF, which is C minus B divided by 2, which equals to C plus B divided by 2, right? And for AF plus AC, it equals to C minus B by 2 plus AC is B, which equals to C plus B divided by 2. See? These two are equal, which means NF divide the perimeter of triangle ABC equally. Okay? So for this problem, basically I introduce a method of calculation, right? It doesn't really like very complicated method. You just need patience and calculate for everything. That is a method for a lot of problems associated with Excenter. So the next time, if you are confused about the Excenter, try to calculate everything, because all of these lengths can be calculated. Okay, I hope you like this problem. I hope you like this video. See you in next one. Thank you.